These are the first two problems on handout 3A. And so these are also mixture problems, but the difference between today's and yesterday's is that the rates are not percents. The rates are dollars per ounce or dollars per pound, or usually dollars per some sort of weight. And let's take a look at the first one. The manager of a food store wants to create a blend of herbs that she can sell for $1 per ounce. So she wants to make something that ends up selling for that amount. So right there, this tells us that she wants to sell it for $1 an ounce. That is our mixture. That is the rate of our mix, $1 per ounce. So right away, in the mixture section, I am going to put $1. That's what she wants to end up having it make. Now, she decides to make 8 ounces of a blend of oregano for selling for $1.90 an ounce, and sage selling for $1.30. So she wants to make. To make tells us that that is going to be the total. So this is the mix as well. And so some key words here. The manager wants to create a blend, to create, so like to make a blend that sells for this amount. So we know that was part of the mix. And then to make tells us, again, that is part of the mix, 8 ounces. And so our next part is asking us for the selling price of or is telling that the selling price of oregano is 90.9. And so we'll just put 0.9 here. And the selling price for sage is 1.3. So 1.3. And we don't know how much oregano, don't know how much sage. And actually, they're asking how many ounces of each are in the mix. And so we just call one of them X. Doesn't matter which one. I'll call the oregano X. Now, the sage is going to be an expression. So whenever you have a total, it always goes total minus the smaller amount, because these two add together to make 8 ounces. They want to make an 8-ounce blend. And when you add X plus 8 minus X, the X's cancel out, so you're left with 8. Well, from there, all you have to do is multiply. So you get 0.9X, and then on the other part, we have 1.3. So it's like 13, basically. So that makes a 24, and then you have to carry a 2. 1 times 8 is 8 plus 2 is 10, and then with the decimal there, so 10.4, and then minus 1.3x, and then this all equals 8. Well, these two add together to make the totals. So let's go ahead and write our new equation down here. We can write it right up here. 0.9x plus 10.4, and then we have a minus 1.3x equals 8. And so from there, we can start doing some opposite operations. So let's go ahead and do that. We'll move that 10.4 over to the other side. Now make sure when you do this, we're subtracting it. Now we got to make sure we put the bigger number on top as we do that subtraction. Make sure you get the right answer. And it ends up being a negative number as well. So we'll go ahead and collect these terms. And we'll end up with a negative number for the coefficient of x. And so we end up with a negative 2.4, and this all equals a negative 0.4x. And so when you do the division, we go ahead and divide by that negative 0.4, and we get those negatives to cancel, and the decimal moves over one space, so x equals 6. So what's x represent? Well, right here, x is the oregano that sells for 90 cents per ounce. And so 6 ounces is what we needed here, and that was the amount of oregano. And then we have the amount of sage. Well, you just put the 6 right here and subtract it from 8. So 8 minus 6 makes 2. So 2 ounces of sage. And that would be our answer right there. Well, another example, same type of problem. Another mixture problem with a rate that's not in a percent form. That's what we'll see on tonight's homework as well. So let's go ahead and read what we got. A grocer wishes to mix some nuts worth 90 cents per ounce. So mix some nuts. So this is not the total. He's going to mix these nuts with some other nuts worth a different amount, $1.60. So those are the rates. So it's 0.9 is one of the nuts. The other is 1.6. To make, keywords there that tell us this is going to be our mix. So that highlights us for us that, okay, this is going to go in the mix section, 175 pounds. So 175 pounds in the mix of a mixture that is worth $1.30, so 1.3. So there it is. That's all we have. How much of each should she use? Well, we don't know that, and so we're going to represent one of them with a variable. Doesn't matter which one. I'll just pick the first one that comes up there. Second one, same sort of thing. Again, we have a total, so it's total minus unknown. And then you just multiply across. So 0.9x, and over here we go 1.6 times by 175. Should get a number bigger than 175, and we do. 280 is what we get, minus 1.6x. And then add these together, they'll equal the total. And so we go ahead and do that math. 175 times by 1.3 gives us a decimal this time. So we have 227.5. So let's go ahead and rewrite our equation up here. 0.9x plus 280 and then minus 1.6x equals, and then we got 227.5. So we go ahead and do some work there. We got to do some opposite operations. Subtract that 280 from both sides. Now when you do that, again, make sure you put the bigger number on top. So I'll do that off to the side here. 280.0 minus 227.5. So you got to borrow a bunch of times. You know, you borrow all the way back from this 8, change that to a 7, change that 10 to a 9, and then do the subtraction. So we have 0.5, do the subtraction there, this makes 2, and this makes 5, and that's it. So we go ahead and do this work here, do that subtraction. We end up with a negative 0.7x, and this all equals negative, we should get a negative because we're taking away, negative 52.5. And so when we do that division, 52.5, we're dividing by 0.7. And so we'll go ahead and show that division here, negative 0.7. So make sure, again, you're moving that decimal point over. And so really it's 7 into 525. And when we do that division, we end up with 75. So let's see what 75 represents. X is pounds. That's what the column tells us right there. And it's of the 0.9. So it's of the nuts that sells for $0.9 per pound. So we have to specify which one it is because there's two. And then do the same thing here. Put the 75 here. Do that subtraction. 175 minus 75 gives us 100. 100 pounds of nuts that sell for $1.60 per pound. So I got that 100 by doing that subtraction there. Well, those are a couple of the problems. The next part we'll go over the book problems that we'll end up seeing. So, well, that'll be on part 2.